This video is to show how simple it is to wire three multi-aspect signals all along the same line. Each will change automatically as the train travels around. The signals can be 2, 3 or 4 aspect. This diagram shows our ADAS4 boards, our mass sequencer board. The train will travel in this direction. The signal is positioned before the ADAS4 board. When the train reaches the detectors on the ADAS4 board, the signal will change to red. It will remain at red until the train reaches the detector on the second ADAS4 board. That will then change this signal to red. Once the train clears the detector, then this signal will go to yellow. This is the correct action because this one mustn't go to yellow until there's a red signal with the train clear of it to stop a collision. The train now travels on until it's detected by the mass sequencer, at which point the mass sequencer signal will go to red. Whilst the train is still being detected by the mass sequencer, this ADAS4 will be at red and this ADAS4 will be at yellow. Once the train clears a mass sequencer, then the mass sequencer starts an adjustable timer. Both the ADAS4s do not have an adjustable timer. This is the adjustable timer on the mass sequencer. You simply rotate it and it will take longer to go red, yellow, green. So it goes from a very short time to a very long time. Once the train is clear of the mass sequencer's detector, then this ADAS4 will go to yellow. This ADAS4 will go to green if it's a 3-aspect one, or to double yellow if it's a 4-aspect one. As the mass sequencer continues timing, it will eventually return to green, at which point every one of the signals will be back to green. I'll just mention our detectors. These are infrared detectors. This is the mass sequencer EW, which means the detectors are on the end of 18-inch long extended wires. One emits infrared, the second detects infrared. So when the rolling stock or any object passes above, the infrared's reflected back from the emitter onto the detector. This board shows our standard detectors. These are soldered directly onto the board, and so the board screws underneath the baseboard and the two detectors again are in a hole between the sleepers. This diagram shows all the connections. There's a 12-volt power supply which powers each of the boards. The red wire obviously is a positive and the black wire is a negative from the power supply. Now the ADAS4 needs to know what aspect or where the train is it being detected of the next ADAS4 up the line. The same thing with this ADAS4, it needs to know where the mass sequencer is on its sequence. And the way that is done is by connecting a wire from the send back to the receive. So that wire is going to say, for example, oh, I'm on yellow, and so this ADAS4 knows, and then it should be either double yellow or green. Again, the ADAS4 here has a wire from the send which goes back to the receive. So this ADAS4 knows what's happening with the next signal up the line. I'll just mention, because this is useful if you've got junctions, if you disconnect the wire from receive through a switch, which is probably operated by your points, then when the receive has no signal going into it from the send, then this signal will automatically go to red. Once you reconnect the wire, then the signal will go back to whatever aspect this ADAS4 tells it should be. Here's two ADAS4s and the mass sequencer, and they're wired exactly the same as on the diagram. To represent the signals, we're just using 3 LEDs for this demonstration. These boards will work with either common negative or common positive signals. You'd need to order the appropriate board. We have made a video which explains the difference between these two types of signals. We've switched the power on now. All the signals are at green. The train travels along past the signal of the first ADAS-4 and it reaches a detector. When it reaches the detector, there's a little LED on the board that shows that the ADAS-4 is detecting the train and the signal changes to red. The signal will remain at red until the train goes past the second signal and reaches a detector on the second ADAS-4. Whilst it's detecting the train, both signals will be at red. But after the train has cleared the detectors, the first signal will now be at yellow because it's safe for the second train to travel. If there was a following train, safe for that one to travel along and reach the second signal because the first train's past that signal now. The train will now travel along past the signal controlled by the mass sequencer and get detected. Again, the signal will change to red. Now this mass sequencer is set up to change very, very quickly, so that's a bit confusing, so I'll change it to make it move more slowly. We've now returned to all the signals being at green, and if another train travels along, red on the first signal, red on the second signal, the train clears that, yellow on the first signal. We now get to a mass sequencer. Again, the signal goes to red. Now the mass sequencer, the train's cleared it, so we've got yellow and a green. I've set the mass sequencer has now gone to yellow, so we get to green there. It would be a double yellow if it was a 4-aspect signal. The mass sequencer continues to time, and we should be back to all greens. I hope this video has shown how simple it is to wire up automatic signals using the ADAS-4s and the mass sequencers. You can do more complicated things because there's a terminal which causes a signal to change to red. For example, if you had a level crossing whilst the gates are set across the railway, you could link this in with a level crossing so the signals were at red, and then that would cause the signal before to be at yellow. There's also what I mentioned about the send to receive wire that can go through the points for conversion junctions, and we also have versions of these boards that operate feathers, so we can have a diverging junction.